So in this video, we're going to be continuing on here in section 8.6, talking about rationalizing the denominator. Essentially, we don't want to have radicals in the denominator. We want to get rid of them. We want to see no radicals in the denominator whatsoever. So what we're going to need to do is multiply the numerator and denominator by a radical that will get rid of the radical in the denominator without changing the problem. And that's the key. We can't change the problem whatsoever. So let's look at how we would do that. So number one, they want you to rationalize that denominator. First thing you would do is, see if you can simplify first. If you can't simplify within this fraction first, then you're going to need to work on rationalizing. If we can get rid of the denominator, that would be awesome. But in this case, I can't cancel anything off with the 7. So I'm left with having a denominator, a radical in the denominator. So this would be the square root of x squared over the square root of 7. So square root of x squared, the squared and the square root would cancel. So this will be x over square root of 7. And if I want to get 7 to be, if I want to get rid of the square root down there, I would multiply by the square root of 7 over square root of 7. Because what that gives me is, on the numerator, x times square root of 7 over, what is 7 times 7? It's 7 squared, right? So this square and the square root cancel. So this is x square root of 7 over 7. Example 2, rationalize the denominator. So 3x, square root of 3x over square root of xy. So again, same setup. Can you simplify anything? No. So this will be the square root of 3x over the square root of xy times, well, I need to multiply by square root of xy over square root of xy. So this will be the square root of 3x times the square root of xy over the square root of xy squared. These would cancel. And in my numerator, I would have the square root of 3x times xy, just so you can see it, over xy. We can simplify that numerator quite a bit. So this is going to be the square root of 3x squared y over xy. Simplifying this further, I could pull out the x to the power of 2 times the square root of 3y. This will be over xy. Square root of 2 and the square root cancel out. So this is x square root 3y over xy. One more piece of simplification, those y's cancel, and I'm left with square root of 3y over y. So this would be my final result. Just a quick note on a problem like this, my rule for my quotient rule allows me to rewrite a radical that's a quotient in this form. So I was able to break this apart and rewrite it as square root of x squared over square root of 7. I could also go backwards and do the same thing. Let me show you number 2 doing a slightly different method. I'll show you number 2 one more time. But this time I'm going to show you it doing something a little different. And this is sort of where it helps to pay attention to what's in your numerator and denominator. So in number 2, I have square root of 3x over the square root of xy. I noticed that my numerator and denominator they're both square roots for 1. And for 2, I noticed that they both have an x. So I'm actually going to go the other way, and I'm going to say this is the square root of 3x over xy. Now, what I notice is I can cancel these x's off. So I get the square root of 3 over y. This problem then becomes, break it up again, the square root of 3 over the square root of y. I don't know the square root of 3, and I don't know the square root of y, but I do need to rationalize the denominator. So I'll multiply by the square root of y over square root of y. So this is going to become the square root of 3 times y over the square root of y squared. Well, these cancel, so I'm left with the square root of 3y over y, which, if you notice, is what we had before. Square root of 3y over y. So these are just two different ways that you can solve this problem. I noticed that there was two x's, so I wanted to get rid of those x's, and you can do that as long as you do it in this way. This is perfectly valid way to do it as well. So just showing you an alternative. This way, this new way, the second way that I showed you, saves you a little bit of simplification work at the very end there. Just another way of looking at the problem. Number 3, rationalize the denominator. 8 over the cube root of 5. So 8, that has nothing special going on, but the cube root of 5. There's no way I can take the cube root of 5. 5 is not a cube number. So this is going to be 8 over the cube root of 5. So if I want to get rid of the cube root of 5, I need to multiply by the cube root of 5 over the cube root of 5. But this only gives me 2 5s. I need there to be 3 5s. So I need to multiply this one by one more. So cube root of 5 over the cube root of 5. And the reason, so when I did square roots, I only multiplied by 2 because I only needed there to be 2 5s in the denominator. Now I have a cube root, so I need there to be 3 5s in the denominator. So this is going to become 8 times the cube root of 5, and we could say 5 squared, right, because that's there twice. So the cube root of 5 squared over the cube root of 5 to the power of 3. This is the same as 8 times the cube root of 5, and I'll bring this 2 to the inside. That's valid, over 5. So you can leave your answer like that. You just want to make sure, since these 3's canceled, you get rid of your cube root there. So either numerator is acceptable. You could do 8 cube root of 5 whole squared, or you could do 8 cube root of 5 to the power of 2. Okay, so that's two different ways you could do number 3 there, or the numerator number 3. But notice I had to have 3 5s because I had an index of 3. Next part, adding and subtracting radical expressions. So when you're adding and subtracting radical expressions, it's just like adding and subtracting like terms. So radical expressions, when you're adding and subtracting them, they need to have the same index and the same radicand. If they don't have the same radicand, then you can't add them. And what this becomes is you're adding the numbers out front. So it's just like combining like terms. So let's look at the first example. Add or subtract, it says if possible, because sometimes it might not be possible. So let's see, I have 2 square root of 2 plus 3 square root of 8. Well, I can't break down 2 any further, but I think I can break down 8. So I'm going to write this as 2 square root of 2 plus 3, and I can rewrite 8 as 4 times 2, because I know 4 is a square number. So this will become 2 square root of 2 plus 3. The square root of 4 is 2. And I don't know the square root of 2. So I'll leave that as square root of 2. So this becomes 2 square roots of 2. 3 times 2 is 6, square root of 2. And I can add these together now because my radicand are the same. So since I have square root of 2 and square root of 2, I can add the numbers out front. I can just combine the like terms. So 2 and 6 is 8, and then I have the square root of 2. So what you would hopefully notice is I didn't change anything inside the radical. The only thing I changed was the number out front. When you're adding and subtracting, you're just adding and subtracting the number out front. Let's look at 2. 9 square root of x minus 4 square root of x. Are these the same? Yes, this is a square root, this is a square root. The radicands are the same, so I can do 9 minus 4, and that's 5 square root of x. You just need your radicands to be the same. Sometimes you might need to do manipulation like we did up here, and that's perfectly fine. 3, add or subtract if possible. 3 square root of x plus 2 square root of y. We're just going to write not possible here. The radicands are clearly not the same. X and y are 2 different variables. So we can't add or subtract them. It's nice they're both square roots, but you can't add or subtract. And that does it for this section on adding and subtracting radicals, multiplying and dividing radicals. And so if you have any questions, please write them down, please, and bring them with you.